Hello, good evening, students. This is Sumit Kundu here. I am alumni of IIT Bombay, and I have been teaching for the past 7 years now to many students who have successfully passed their IIT, JEE, and other competitive examinations. And it gives me a great pleasure to introduce to you a modular course on optics, and specifically what we'll be looking at is your lens theory, students. Okay. Now here I have brought in a few concepts also from your refraction, and that is also something that we'll be doing here today. Okay, so put on your seatbelt, guys, and let's get started with your few very basic and important questions on. This I'm sharing my screen here with you guys. So let us just get started here, students. Now, students, I'll get right away started off, okay, without any other discussion. So the first thing that we're going to talk to you is about lenses. Okay, lens. Now see, lens has got two curved surfaces. All right, so this is my curved surface number 1 and this is my curved surface number 2. They'll have two different radius of curvature and they'll have two different centers of curvature. All right, so this is what technically defines my lens. Okay, so technically I would say that a lens has got two focal lengths. Okay, one is called as your principal focal length and the secondary focal length. Okay, so I'm not going to do all that, which is called as your principal, which is called as your secondary. I'm not going to go deep into those things. All right, I'm just assuming that you basically know certain things about them. All right, now what I'm going to focus on, students, is the sign convention. Sign convention, students, is one gray area that all students face. The sign convention. There is a little bit of a confusion with all students with respect to sign convention. Okay, so that's the reason why I brought this out here. All distances measured from the optical center. Okay, all distances, this is my optical center out here. Clear? And students, all distances are measured from that particular point. Now, distances measured in the direction of incident rays are always taken as positive. Remember this particular point. Distances measured in the direction of incident rays are basically taken as what? Your positive. Clear? Now let me explain this to you a little bit before we can go ahead anyway. All right. Let me take a lens. Students, let's say this is my lens. Let me give it a green color. And let me define its principal axis out here. I'll use the black color here. Say this is its principal axis. Clear, students? And then an object has been placed here. Let's say this is the point where the object has been placed. So this is the point where I have my object. Clear, students? Say this is the principal axis. I'll denote it by, let's say, C. Take it, this is the center. This is the principal axis. So this is the optical center. So students, the optical center here is what is the origin that I could say. All right, and the image gets formed somewhere out here. So this is the location where the image is being formed. Clear, guys? Okay. Now here, just a second. Give me. Okay. Now what they said is like all distances are measured from the optical center. So this is like, you know, the origin from where I'm going to measure everything. So students, if you see, use a convention that is used for object distance. Object distance. Now here, students, what do you see? Object distance. Is it going to be positive or negative? Definitely in this case, it is negative. Because students, light is traveling from the object, isn't it? So light is going to travel in which direction, dosto? Light is going to travel in this direction. So basically, students, this direction is considered as positive. Clear? This is being considered as positive. And the opposite direction, because while we are going to measure the object distance, we are going to measure it in which way? This way, because it is being measured from the origin. Clear? So when I start measuring from here, I got to go in this direction. Clear? So in that direction, if you see, my u is what? Negative, guys. Similarly, if I'm talking about my I is going to be measured this way. So for this, I am going in the direction of the light, which is positive. So my V, which is the image distance, students, which is the image distance, it is going to be my positive. I think the simple basic idea of the sign convention is kind of clear to each and every one of you. Okay, let's just move ahead now. I've taken few questions, students, randomly from previous years question papers, KVPY, and some few very interesting books on optics and physics. Clear? So this is just a few of them that I'll be doing here, and in the modular course, we'll be doing a little more in depth and little more elaborate questions out there, more interesting ones. Okay, that you would find very exciting for sure. All right, so let's just get started with this. Students, it is about cutting of lenses. This question. This is based on the concept of cutting of lenses. Students, I could cut the lens in two different ways. All right, so come and let's just see. I could basically cut it this way, or I could go on ahead and cut it in this way. All right. Now, students, simply if I am making it cut along the x-axis axis, then what I'm going to get is a portion something like this, right? This is the top portion out here. So this is what I'm going to get. All right. And if I make the cut along the y dash, then students, what I'm going to get? I'm going to get a part something like this and this. Students, when the thing is being cut along the x-axis, x dash, let's say, the point to remember is focal length, dosto, does not change. Does not change. Clear? However, here the focal length will actually change in this case. So what happens out here? Second point, intensity of the light decreases. Intensity, or let's say intensity of the image, is less. Clear? So it might be appearing a little faded kind of a thing. You will not get a very sharp image. So that is what is going to happen in this case if you make the cut along the x-axis. Okay, and if you make the cut along the y dash, students, we want to know what is going to be its focal length. Say it is f1. तो यार इसका भी वही होगा f1, isn't it? Now, see students here, this one also f1, this is also f1. So let's see, this original lens out here had a focal length of f. Okay, so if I combine these two, I should get this, isn't it? So here I can say my 1 by f1 plus 1 by f1, that is the focal length of this, and the focal length of this is equals to 1 upon f. All right, students, this is a simple general formula that I want you to remember. That is 1 by f effective, okay, is equals to 1 upon f1 plus 1 upon f2 plus 1 upon f3, and that depends on how many more lenses you're keeping in series with respect to each other. Okay, so here if you see, this will become 2 divided by f1 is equals to 1 by f, which implies my f is going to be equal to what? I mean, my f1 will be equals to nothing but 2 times f. Clear, guys? So the focal length of each piece out here that I have obtain by cutting it is actually 2 times the original focal length. All right. So the summary of this entire thing is, if you cut it along the x dash, the focal length doesn't change. If you cut it along the y dash, the focal length doubles. That's it. Okay. So chalo guys, let's have a look at this question out here, which we had put. So in case I cut it this way, but chalo, I have got like 4 parts. Now I'll use a broader one, 2, 3, and 4. Clear? So this is a part 1. And each one has got a focal length of how much, students? Absolutely correct. 2 times f. So this is also having 2f. Alright. Because when I made this cut, focal length is not going to change. When I made this cut, focal length is going to get doubled up. So when I just take part 1 will also have 2f, part 2 will also have 2f, part 3 will also have 2f, and part 4 will also have 2f, students. Then what can I talk about the effective focal length which I'm going to get from here? Nothing but 1 divided by 2f plus 1 divided by 2f plus 1 divided by 2f plus 1 divided by 2f. So this is like 4 times 1 divided by 2f. So if you solve this, students, this is like 2 by f, which implies your effective focal length is going to be f divided by 2. So what is the answer here? This is what I get as my answer, students. Okay, students, this is appeared previously in your JEE mains examination, a similar concept, and definitely in multiple examinations related to, like, your state level engineering examinations. Request, I mean, you can go through that once again. All right, it is going to help. It's going to be helpful to you sometime or the other, I'm sure. Okay, chalo guys, without any further delay, let me take another one. There are multiple of questions here, so let us just spend time with each one of them, and let's try to do justice to each one of them. Okay guys, see, there's a bird wala, बहुत standard question है, ठीक है? There is a bird and it is flying over a swimming pool at a height of 2 meters from the water surface. If the bottom is perfectly plain reflecting surface and the depth of the swimming pool is like 1 meter, then I have to find out the distance of the final image of the bird from the bird itself. And they have given us what is the value of your refractive index of the water. Okay guys? Now chalo yaar, very simple. Isko pure ko we have explained out here. So there is a pond which is water up till, like, which has got water up till 1 meter height. Okay. And here 2 meters above the surface, there is a bird flying out here. Okay. Now see the students, this bottom of the pond is like, plain reflecting surface. Okay, so here in this question that we would be seeing, there are, like, multiple phenomena are taking place. All right, students. Now, when we have got multiple phenomena taking place, the idea that you need to remember is the image of the first phenomena, okay, acts as the object, right, for the second phenomena. Okay, that's a basic idea, that's a basic concept that you need to remember. When you have got multiple phenomena involved in a question, the image of the first phenomena will act as the object for the second phenomena here. So students, here I see a bird flying here. So is this bird going to be appearing to any eye which is just like here, just below the surface out here? Clear? Is it going to appear to be at 2 meters? No. If you see here, anywhere in this range that I put my eye, I can see one ray is going to come here, refract, bend towards the normal, clear. And if I produce it backward, the image is actually being formed here. So the bird appears to be even further away, all right, than its actual position. So this is, students, my actual position, all right. And this is what it's like, the image is where it is being formed. Okay, done, everyone? Now, students, I'll tell you one simple logic. If the rays are traveling from denser to rarer medium, we divide it, in order to find out whatever is the apparent thing. If it is traveling from denser to rarer, that means, very simple, if the object was in the denser medium and the observation is taking place from the rarer medium, then d apparent is like, your d real upon mu. Okay. However, just the opposite of it is going to is what is happening out here, students. The object is in the rarer medium and the observation is from the denser medium. Okay. So in this case, your d apparent, or let's say rather than saying depth, it's the height apparent. Height apparent is equal to mu times the actual height. Okay, mu times the actual height. So in this particular case, where do I see the bird? 2 meters above. Okay, but then actually this distance is going to be how much? The refractive index of water is given to us. Mu is equals to 4 by 3. Then students, here this distance from this point to this point is going to be nothing but equals to 4 by 3 into 2. So that is mu times the original height. So that becomes 8 divided by 3. Take it. Now, students, this is my first image. Now this is going to behave as the object for my second phenomenon. Now what is my second phenomenon? Now, second phenomena is that light is traveling here. So its image is where? It's out here. Now, this is acting as an object for the second phenomena, which is the reflection at the plane surface. So here the second phenomena is reflection at plane surface. Clear, guys? Guys, stick to it. I have got very interesting problems coming up ahead of me. Okay, hold on to your patience. You can watch this video multiple times. Okay, try to focus. Let me tell you, once one concept is like, clear. I mean, if I tell you, like, all the concepts I have used here, if you remember all these concepts, you can actually crack any question for optics. Okay, chalo, let's go ahead here. And we are seeing here that this distance is like how much then? This is 8 by 3 from this point to this point, it is 8 by 3. You add another 1. How much will it become from the plane reflecting surface? 8 by 3 plus 1. So that is nothing but 11 by 3 meters. So where is the image going to form behind the surface? Same distance. So this distance from, let's say, A to B is nothing but 11 by 3 meters, guys. All right. Now, that is my second one. Clear? Now, the third one. There is a third phenomena as well. Can you guess it? What is it? That is, again, the refraction from the denser medium into the rarer medium. So, what is the depth of the object from the surface? It is nothing but 11 by 3 plus this distance again. All right. So third phenomena, it is the refraction from denser to rarer medium. Clear, guys? Okay. Now let me take up a fresh page. All right. Now in that, what we can do is, this distance now we know is 11 by 3. Isn't it, students? That is like from, if you see from the plane reflecting surface, that is, this distance is 8 by 3 plus 1, so that's 11 by 3. So from here to here, it is 11 by 3. Now for the refraction at the, at like, this surface, from here to here, it is 11 by 3. You add another one, you will get the net depth is 11 by 3 plus 1, so that is like 14 by 3 students. Okay guys, now here let us just focus with just coming to a closure out here for this question. For the refraction from the denser to rarer medium, D apparent is going to be D real, which is nothing but 14 by 3, and mu is nothing but 4 by 3. So this is what I have, that is 14 by 4. So that's nothing but 7 by 2. Okay. So 7 by 2 is the depth from here. All right. So somewhere maybe out here it will come to. Plus they have asked us the distance from the bird itself. So another 2 meters. You add to it. So the final distance is nothing but 7 by 2 plus 2. So that is nothing but 11 by 2 meters, students. So we look at the options here, and this is what we get. This is the distance of the image, the final image of the bird from the bird itself. Okay, I hope you're enjoying this question, students. So we have a pack of many more of them coming up. So stay tuned and let's just have a close look at this question here. A point source of light. Okay, a point source of light is placed at the bottom of a vessel, which is filled with water with refractive index mu to a height h. If the floating opaque disk has to be placed exactly above it so that the source is invisible from above, find the radius of the disk. Now students, these are like, pretty much of a shortcut kind of a questions that we will be doing. We are going to apply few concepts which is going to be very, very important. What are they saying in this question? Let's just understand that. There is an object which is placed here. There's an opaque disk, and just below the opaque disk, below it, out here at this point, they have placed a source. Okay? Now light would be going out here. All right. And what are they telling us? All right, just go through this question once again. If a floating opaque disk has to be placed exactly above it so that the source is invisible from above. Now, if the source is invisible, what does it mean? Students, the only story out here that I can say about invisible is that rays from this particular source is not able to escape the water surface. All right, very simple logic. If they are not all right, so this opaque disk is definitely going to cover out here, because whatever rays are going to fall, let's say out here, is not going to escape because of the opaque disk. And here in this region, beyond this region, let's say the angle of incidence is such that it is greater than the critical angle. Now in such a case, what is going to happen? If angle of incidence, students, is greater than the critical angle, then what is going to happen? Total internal reflection. Okay, so rays which are coming here, they are being blocked by whom? They are blocked by this opaque disk. Clear? So the opaque disk is blocking all the rays which are like, here, or let's say like, going and hitting here. So I need the opaque disk only for this region, because from the region from here and above, my I is greater than C. So light is anyways not going to go. We don't need any opaque disk for that particular region. Okay. Then here, students, I can see then my sine of I should also be greater than sine C. Okay. Now, what is sine of I? In this triangle, let's have a look. Sine of I is nothing but R divided by this hypotenuse out here. And what is the value of the hypotenuse? If you look at this as the height h, root over r square plus h square is greater than sine c. Students, all of you know that sine of c is nothing but 1 divided by mu. I hope everybody knows this. All right. It's a pretty standard result that we should remember. All right. So sine c is nothing but 1 upon mu. And then we take the limiting case, my dear students. So what is the limiting case? That is the point from which the light stops going into the another medium. That means the point where the reflection will start taking place. Okay. So in that particular case, your r divided by root over r square plus h square will be equals to 1 upon mu, which implies, my dear students, mu into r is equals to root over r square plus h square, which implies, now it's like, simple solving, students. Okay, what was important out here? This concept is what was important out here. That is, the angle of incidence is greater than the critical angle. And if you solve it, you get mu square r square minus r square is equals to h square, which implies my r is equals to h divided by, okay, root over mu square minus 1. Clear? So this is the answer to this particular question here. I hope everyone's understood the basic logic behind this. This was the fundamental logic that you need to remember. Okay, guys? Chalo. With very less time in hand, we would want to make most utilization of the time that we have out here in our hand. So let us just quickly have a look. Now, students, here I have got 3 scenarios, 1, 2, and 3 out here. Guys, very simple. They have asked us, like, how many images are going to be formed. Clear? In case 1, case 2, case 3. Students, understand one thing. In this case, I have this as one region, this as another region, and this as another region. However, see, number of images, I'll tell you the concept here. Number of images formed will be equals to a different number of focal lengths that we can have. Different number of focal lengths. Clear? Now, here this region will have one focal length. This region will have another focal length. Make a formula which is equals to mu relative minus 1 into 1 divided by R1 minus 1 divided by R2. Students, very important formula that is required to be remembered by you guys. Okay, now if you use this formula here for portion 1, portion 2 and portion 3, you will see that my F1 will be equal to your F3. So though we have got 3 regions, this and this region will give me the same value of the focal length. Clear? So in case number 1, there is not going to be like, one image. There's not going to be like 3 images for case number 1. This is wrong. All right. So there is going to be how many of them? There is going to be just 2 of them. Clear? So anyways, my option A is not correct. Clear? However, I would want, in this case, you people using this equation out here. It's a biconvex lens cut into 2 identical halves. This is an important thing, and they are placed in different ways as shown out here. Okay, so these are like identical, so you can just take like R and R. And here they have asked us to find out. So this is not the option. Obviously, second one is also not the option. So third one, among third and fourth, which is the right answer, we need to find out. Okay, guys. Now I want you to solve from here and get the right answer. Okay, and let me see how many of you can solve it and revert back to me at my WhatsApp number with the most appropriate answer for the above question. Clear? So let's see. I mean, like, how many of you are the smart ones watching out on this video? Clear? Shallow guys, I'll not take much more time in that question. Rather, let's do a more interesting question from your concepts of refraction. Clear? Now here, this eye, I mean, this is a cubical vessel. This end is visible to the eye out here. Clear? This end out here is visible to the eye. So the rays are going along this direction. So this is what? This is nothing but the line of sight. This is the line of sight. Clear, guys? Now, the thing they're saying is, if I place the object here, say this is like 10 centimeter, I put it inside, then definitely this doesn't fall into the line of sight. Nobody can watch it. I mean, definitely this eye is not able to watch it. Then they are saying, if I start putting water into it, then the rays coming from here at this surface may bend and travel along this direction, so that this end, or say this point, is also visible. Clear, bachalo? So this is the entire idea out here. Okay. So we need to pour water in order to make this mark visible. This idea is clear, isn't it? Now they are asking us in this question, what should be the height of the water level? We need to understand what should be the height of the water level. This is what they have asked us to figure out. Clear, guys? This question is very, very straightforward. I have taken a fresh diagram out here. Acha, students, understand, this is a cubical vessel. So this length is x and this length will also be x. So what will be this angle, students? Absolutely correct. It should be what? 45 degrees. Clear? So if this is equal to 45 degrees, all right, students, then what I'm seeing here is, for this ray which is traveling from the object that got displaced by 10 centimeter. Okay, guys. See, the time is so less and I want to give you so much more, but you just can't help it here. Okay. So definitely in the modular course, we are going to look at specifically the questions on your lenses. However, just before that, a little warm up on refraction was very much important. So that's what I have introduced into this session on, like, the free session out here. Okay. Now here, students, we kind of see the rays are traveling from the object out here. It is going to bend here and it is going to go in this direction such that it reaches the eyes out here. Clear? हाँ, बच्चा एक चीज देखो, at this surface when refraction is taking place, then what can I say? Mu times sine of I is equal to, or let's say mu water sine of I is equals to mu air sine of R. Okay. Now here, what is R equal to? Nothing but 45 degrees. Because these are what? Parallel lines out here. These are parallel lines. If this is 45 degree, definitely this is also 45. And this angle out here are what? Corresponding angles, students. Okay. So this is also what? This is also 45 degrees. So mu water is nothing but 4 by 3 sine of I. I don't know what is I. This is 1 into sine 45. So that is like 1 divided by root 2, which implies my sine of I is equal to 3 divided by 4 root 2. Okay, students. Now here, if I take a triangle, my dear students, all of you, if I take a triangle out here, sine I, so if let's say this is my I, clear? Then this will be 3 and this will be 4 root. Okay, guys. Now, as for that, this base out here is going to be root 23, which we can find out by using the Pythagoras theorem, guys. Okay. Now, what is the main point we see here? We want in this triangle, from this triangle, we should be able to find out whatever is the height. How? Take tan of I. What is tan of I? This distance from here to here, how much is this? If you see here, this is in this triangle out here. This angle is 45. So if this is h, this distance will also be h, isn't it, students? Right? If this is h from here to here, if this is h, then this distance also should be equals to h. Now, if we have taken this as 10 centimeter, then this distance is going to be how much? H minus 10 centimeter. Clear? Then what is my tan I going to be? This distance is nothing but h minus 10 upon h. Got that? What is tan I, my dear students? See, this approximation we all know. We have been doing it. It is sine of I is approximately equal to I is approximately equal to tan of I for all small angles. So this is exactly that what we are going to follow here. So tan I is going to be what? No, we are not going to take it approximately equal to this. Okay. We have got definite values that we have figured out. Isn't it, students? Because the angle is kind of not small out here in this case. Okay. So we will not take that. Rather, we will take tan I is 3 divided by root 23. That was just fooling around with your minds. We have sometimes that idea, we feel lazy at times. So sin I is given tan I, we can find out by taking tan I is equals to sin I. And in optics, we do pretty often, but be careful when to use it and when not to use it. So 3 divided by root 3 is h minus 10 upon h. If you see, root 23 has got a value of approximately 4.8 is equals to h minus 10 upon h. If you solve this entire thing, if you solve this, you will get the value of h as 26.666, which is going to be approximately equals to 27 centimeters. All right. So that's the fair idea in this particular question out here. So that's what is my answer, 27 centimeter, my dear students. Clear? Chalo guys, we'll take up the last problem for today and then we'll meet up with you in my session on the modular session on your optics. Clear? Now, here, this question I'm going to do in my session, rather I'll not do it here today. That is, if I've got a flat plano-convex lens, a flat plano-convex lens is looking something like this, okay, where one side is kind of silvered, okay guys, so it's like one side is fully silvered, clear? So if this one side is kind of silvered, they want us to find out what is going to be a point source space 30 centimeter in front of a curved surface. So here in front of this, you're placing something at a distance of 30 centimeter. So this is the object out here. They're asking us where is going to be the final image, location of the image. Let me see how many of you can actually, if you're able to solve it before the session itself, okay, I would be really obliged and pleased for you to have done that. Okay, so you can WhatsApp me at 830-880-7045 or During the session, we are definitely going to discuss on this particular problem out here. Okay. Now, I am skipping this just because I've got one very interesting problem out here, which involves a little bit on your wave optics as well. Okay, I'll give you a hint and a clue, and let's see how many of you are able to do it. Students, I hope everybody knows your Young's double slit experiment. Now, in your Young's double slit experiment, my dear students, what we have is we have got two sources, but here I have got just one source. But not to forget, there is a plane reflecting surface out here. So this is my reflecting surface. Clear? Now, here in the plane reflecting surface, what is going to happen? It is going to have a reflection out here. So there's going to be another source coming here, call it as your S1. Now, these two are going to act as my two slits, and they are going to form an interference pattern on the screen out here. That is the beauty of the question, how they have used optics, ray optics, and put that into your wave optics problem. Okay, students, it is not at all difficult. If you would see, this is what the scenario is going to be looking like. You have two of these sources out here, and we need to find out what is the value of the fringe width. Fringe width. Now, as some of you might be wondering, wave optics तो वैसे नहीं समझ में आता है. Just understand there are basic formulas here. Beta is equals to lambda capital D by small d. This is the formula for fringe width. Lambda is given to us in this question. We technically need to know what is capital D and what is small d. Capital D is the distance between the sources and the screen. From here to here, it is 100. This distance is given to us is nothing but equals to S from O is 20 centimeter. So that is given to us. This is 20 centimeter. So we can technically look at this triangle and find out this value, call it as say P. So PO plus 100. So that is nothing but SO cos theta plus 100. All right, and D is nothing but 2 times SD. SD is this distance, so that is like 2 times SO sine theta. Okay. Achha guys, now what about your theta? Theta is the angle which is given to us out here. Theta is being given to us. Now, one approximation, sine theta will be approximately equal to theta for small angles, all right, and cos theta will be equals to 1, same reason for small angles. Clear? Use all of this, insert into it, and tell me what is the answer. Message me at 830-880-7045. Let me see how many students are interested to take this course forward, students. Okay, now here students, one thing is for sure, in order to register yourself for the modular course, what you need to do is that you need to visit a link. All right, now let me just see. I'll now the screen is not visible to you. I think it's just me in front of you right now. So I would take this opportunity here, okay, to tell you that this course out here, students, is just 2 hours course. Now, the thing that I'm wondering, you must be wondering is what would we actually learn in this 2 hours? So being very specific to you, I'm going to do lenses, all right, and I'm going to stretch on the point where you need to work on The sign convention thing. So like, in multiple problems that I'll be taking, I'll be like, completely talking about your sign convention, and that is what I want you people to also focus on. Okay. Now, sign convention, if that is taken care of, and 60% times questions have been coming in JEE mains from your lens theory, and that we have observed is a trend over the previous years. All right, guys. So that's what I would want even you people to follow that trend, okay, and actually like stick on to the convention of like the lens theory and the sign convention. If these two things have been done very nicely, there's a 70% chance that you will be able to crack the question that is going to coming for your JEE mains. All right. Now here, students, there's a link which I'm going to just share with you. All right. What you can do is you can visit this particular link out here. Clear? You can visit this link and click on this link in order to register for the course. And let's chalo then, guys. Let's meet up during the course time, wherein the basic thing that I'm going to be looking at is your lens theory, all right, and proper use of sign convention. So these are the two aspects that I'm going to be covering in the modular course, which is going to be of length 2 hours, all right. And for early registrants, I might be sending across a few very good questions post the session. Pre the session as well as sometimes post the session, I'm going to give you a collection of like something around 15 to 20 very nice problems, okay, on your lens theory, which is going to be real brain boosters for you guys. Okay, chalo guys, then I hope you enjoyed our session today. Okay, and in order to know more, uh, keep locked in to the session, which is going to start up very soon. Regarding the date and everything, you can just visit the link and get all your queries rectified. Okay, chalo guys, then bye bye. Take care, all of you. Good night.